All right, review of conics. So here's a page of everything you need to know. First, we have circles, so just a little refresher. General equation looks like this. We have an x squared and y squared. Remember that this is the radius squared, not the radius. And then the graph looks like this. We have the center, and it goes out from the center r units, or the distance of the radius, and you can plot 4 points and then connect them with a nice smooth circle. Notice how if we were to divide this equation by r squared, we would end up with this: x squared plus r squared over y squared plus r squared equals 1. This is the same equation as this, okay? And notice how suspiciously similar this looks to the equation of an, you got it, ellipse. So this is just like the equation of ellipse, where a and b would be the same distance. So instead of the ellipse being like this, it would be like, that's supposed to be perfectly round there, it would be like this, and lo and behold, that's a circle. Aha! So equation of a circle, very similar to equation of ellipse, except a and b are the same. And then we looked at circles. Next week, we're going to be shifting the other 3 conics, but we've already shifted a circle. So here's a circle with the center not at the origin. It has been moved to the right by h and up by k. So let's draw that. It's been moved up, and I'll color code here. This will be fun. So where are we? Here we are. So right by h, color coding, and up by k, color coding. Remember, it is always reversed, right? So a negative sign indicates to the right or up, positive sign indicates to the left or down. You might want to write that there. Plus indicates left or down, minus up and right. Let's see. So I have translated this into words, right by h, up by k, and here's my advice. If you're graphing a shifted circle, move the center first. So from 0, you're going to go up and down or left and right. Then use the radius to plot points. So we would have moved the center and then gone r, 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 and r, and then drawn a nice circle. Okay. So from circles, we moved on to ellipses, and take a look. The ellipse can either be squished to the side or squished up and down. And if it's squished to the side, it means x has the larger number underneath it. And if it's squished up and down, it means y has the larger number underneath it. So in defining and using these variables a and b for the ellipse, a is always the big number. That's where we find the vertices. So these would be the vertices. Maybe we should write that. Vertice, vertice. And for this other ellipse, these would be the vertices. Vertice, vertice. B is the smaller number, and that provides the minor axis. So major axis, minor axis, minor axis. You might want to label those. Remember that the eccentricity of the ellipse is a measure of how squished it is. That would be another good thing to write, a measure of how squished it is. And the eccentricity is always between 0 and 1. Be another good thing to write. So, okay, fine. I'll write it too. 0, E, 1. And a measure, how do we spell measure? Of how squished. And what would be a really squished ellipse? That's right, if the eccentricity were close to 1. A circle has an eccentricity of 0. That's because the focal points, basically C is 0. The focal points are right on top of one another at the center. Okay, so what other information do we have here? In the equation, there should always be a 1 on one side. Alright, so notice how there's always 1. Sometimes we have to divide. For example, we had a situation like this. Let's see. Yeah, so something like that, where in this case we would divide both sides by 64 so that we had 1 and we have x squared over something, y squared over something, and those somethings are very likely going to be perfect squares. Sometimes you may find a little challenge when they're not, but probably not. Well, actually you will, but not very often. Okay, parabola. So first, we have 4 different types of parabola. They can open to the right, to the left, up, or down. Dorville. You silly goose. That's opening to the right. Just testing you. And now my stylus isn't working. That's to the right. This is to the left. This is to the up. And this is to the down. Yeah. And up and down, this is what we learned first. You learned first when you were in Algebra 1 and Algebra 2, these parabolas that go. And so there was y was all by itself and x was squared. And we can also have parabolas that go left and right like this. Okay. So basically, when graphing these, the coefficient we set equal to 1 over 4p, where p, poor p doesn't have a real special name other than p, but p, this variable, really defines the parabola and its shape. So we have that this isn't the center of the parabola, we call it the vertex of the parabola, and p and p are the distance between the vertex and the focal point. I'm going to zoom in here. There we go. P is the distance between the vertex and the focal point, and it's the distance between the vertex and the directrix. Okay, and then the width, or focal diameter, of the parabola is 4p. 1, 2, 3, 4. Okay. Notice the thing that a lot of students will get confused by, this directrix is a line, not a point, right? It's not just a point here, it's the whole line. And it's going to be, so we could describe it using the equation of a line. And in this case, it would be y equals negative p. I'm going to say in this case. Because if the parabola opened to the left or to the right, it would be a vertical directrix. So, okay, great, that's all the details about graphing a parabola, but what is a parabola? Well, it's that curve shape, but more. Parabola is the set of points where, so here's a point, all right, the distance from the focal point should be equal to the perpendicular distance to the directrix. So using some geometry symbols, we can go indicating congruent segments or the same length. Ooh, look at that connection. All right. That was cool. And then lastly but not leastly, the hyperbola. Again, hyperbola is not just two parabolas, right? It has these asymptotes that it approaches and approaches and approaches and approaches. So this right here, this drawing is almost a little sketchy. See how it starts to curve? Bad, Torville. It should get really close to the asymptote. That's approaching the asymptote. Really nice and close, really nice and close. All right. So, similarities. All right. This is opening up and down. Notice how the vertices went in the y direction. Notice how the positive term is the y squared. And over here, the positive term is the x squared. So notice how the vertices went in the x direction from the center. Okay, so for the hyperbola, it's all about which term is positive. I'm going to write that. All about which term is positive. Right? That's going to tell you where the vertices are. Vertices. With the ellipse, however, it was all about which number was bigger. And this statement in itself is vague, but all about which number is bigger. And I'll put vertices or squish, right? Does it open up or down or left? Not open. Is it squished up and down or squished left and right? Okay, back to the hyperbola. So I'm just trying to compare, contrast, so we get all our facts straight and relate them to the other shapes. So the positive term, a is the distance to the vertices, right? Here a is under y, here a is under x. A and b, so here, and this is really similar to, I'm just phrasing it differently. I was writing it and I didn't know that I had it written down there. But this is kind of steps we can use to actually graph. Figure out where the center is, which in this case would just be 0, 0. Draw the box, that's A and B. We use A and B to draw the box. A and B, and then the box, the rectangle. Through the corners of the box go the asymptotes, and then vertices. So that's these points. If we're drawing A and B, we already have the vertices drawn. And then the foci, or focal points, and then we're going to graph it. Not just two, so this is wrong. Right? Not this parabola, it should approach the asymptotes. Okay. And then the other, if we're comparing and contrasting, notice how the hyperbola has a negative sign. So let's write that in there. All right. Has a minus sign and S-I-G-N, that's an N sign. And then for the ellipse, has a positive sign, plus. All right. So this is all the information you need for all of those shapes. We're going to do some practice with graphing and going from the graph to the equation, but look at all that beautiful stuff. Okay, thanks for listening.